Good morning and welcome back to the lecture series. In the last couple of lectures, we have discussed about the details of the CNC system, and whenever we talk about the entire manufacturing system of the factory level of computerization, then the next topic would be the flexible manufacturing systems. If we think about the CNC machine, robotic system, coordinate measuring machine, or computer-aided quality control system, these are island of activities. But when we put together logically to give a completely factory or shop level concept, then we have to consider the flexible manufacturing systems. Although there are two simpler versions, we will also discuss, known as flexible manufacturing module, then flexible manufacturing cell, and finally we will have the flexible manufacturing systems. These systems will give us a complete manufacturing mechanism by which raw material can be converted to the finished goods or particularly to a sellable product by conglomerate or aggregating the machine tools, the material handling devices, the tool management system, inspection systems, assembly, automatic palletizing, depalletizing, and of course everything should be, or the activity should be coordinated under the supervision of a central computer. With this, let us move to the content. So it is always imperative to have a look about the background. What is the automation, or what are the different categories of automation, the benefits, the level of automation, then flexible manufacturing cell and flexible manufacturing systems. So automation is basically combinations of different technologies put together in logical and synchronized manner to accomplish some objectives or tasks in an unmanned manner. So there are certain key words that we have to consider and we have to think very meticulously. It is of course the combinations of different technologies which are put in a logical fashion, of course in the synchronized manner. How the machine tool activities, loading, unloading by robotic system, inspection, other transportation system, and of course the tool management and the overall computer control system, how they will be synchronized and coordinated, that aspects to be considered so that we can have a typical or predetermined objective or task which can be accomplished, and most importantly the unmanned manner. That means execution and control and coordination all are taken care of by non-living systems in coordination with different modules so that we can accomplish the task in an unmanned manner. Types of automation: hard automation and programmable automation predominantly. Apparently, it may seem that automation term is intertwined with only the computerization, but even well before the computerization, there was automation, but those automation was accomplished not by any software or computer, rather mechanical hardware or mechanical components were used predominantly by say camshafts, dogs, limit switches. Those items were utilized to execute different control activities in a machine tool system. But why these are called hard? Because of their rigid in nature. These are fixed, these are rigid and not suitable or not amenable for the changes. That means for your high production machines or the quantity production machines, there were automation using the limit switches, camshafts, clutches, but these are rigid and inflexible because of the fact a particular cam profile will exert or will yield only a definite type of motion. If we are looking for, or if our objective is to go for any changes or the modification, the system will not permit. That is why for only one particular motion, the performance would be extremely well. But if our objective is to go for certain changes, the same system will not permit, and that is why it is called rigid and fixed. So whenever flexibility is important criteria, so that we can switch over from one job to other without making marked changes in the hardware, this system will collapse. So that is why hard automation was not prevalent in the days of batch manufacturing and most predominantly with the mass customization or the mass personalization. CNC system in contrast offer programmable automation. As the name suggests, that means it is programmable. So operation sequence can be altered and controlled. Whenever we talk about the alteration, That means there is adequate flexibility. So that flexibility can be achieved only by changing the software program. So the sequence of activities can be altered and control is exercised by software programs which permits greater flexibility leading to intelligent decision making. So under the IMS paradigm, whenever we talk about the automation, it is definitely a programmable automation. Another version which is basically extension of the programmable automation, that is in broader perspective is called flexible automation. So it is an extension of the above where the changes can be made without restriction. Now how to distinguish the flexible automation from the programmable automation? Programmable automation allow changes within certain limits or within certain model or variants of a particular product. But theoretically, if we talk about any sorts of changes without any restriction, then we have to think about the flexible automation. But honestly speaking, for any organization considering the limitations of the fund and the facilities, it is never possible to switch over from any arbitrary job sequence to completely and abrupt changes where the existing system will not be able to accommodate within their predefined capacities. So within a specific zone, this adaptation or the flexibility is possible. But if we think about for any jobs, we can switch over to any other jobs without any restrictions in their complexity, their capacity, their specification. The system is practically not or economically is not viable. But for the theoretical context or theoretical point of view, we can have a definition which we call the flexible automation, where the programmable automation can be extended to accommodate any changes. What are the benefits that can be added whenever you are in business? So one of the very fundamental key performance indicator is productivity. And since we are in the flexible domain of manufacturing, flexibility is our main criteria. So enhancing productivity and offering higher flexibility, both are two major key performance indicators of the automation. Additionally, reduction in labor cost and to get rid of labor shortage. If we think in the light of the definition, to get the work done by unmanned manner, that means the objective is to cut down the labor force. So whenever there is a possibility of the labor shortage, the automation provides excellent opportunity as an alternative. To ensure worker safety and reduce fatigue, majority of the activities are now taken care of by the programmable board. So operator of the human intervention is rather less. So that is why the possibility of the fatigue is very less, and at the same time there may be a lot of features which can be accommodated or incorporated that can successfully and efficiently take care about the workers' safety. Just for instance, if we think about our CNC machining system, there is a possibility of accident unless you have a certain precautionary measure. So closing the glass door, unless and until the glass door is closed, the system will not start functioning. So that is an embedded worker safety feature. Likewise, more such safety features can be incorporated. To achieve consistent quality and reduction in scrap, since it does not depend on the human skill, therefore we can achieve the very good quality which is really consistent. To improve accuracy of the product which eventually will be developed or manufactured by using these state-of-the-art automated technologies, we can assure very consistent and accurate quality of the product. To reduce manufacturing lead time. In the programmable mode, whenever different activities are coordinated very efficiently, then the lead time will definitely come down, because your transportation time or waiting time, this will be cut down very substantial amount. To have a competitive edge over others. With this sophisticated facility, we can better address the customer requirements. So in that case, with that competitive edge, we can beat the other competitors. Additionally, we can have automatic fault diagnosis, error recovery, and intelligent decision making. So depending on the capability of the program, a lot of macro programming facilities are also available. So those facilities also help us to automatically diagnose the fault and to take corrective action that reduces the hazardous activities associated with the maintenance problem. And of course, it facilitates intelligent decision making. So all these things eventually lead to reduction of the cost, which is the most cherished criteria of any business organization. Now, if we categorize the automation depending on its level of complexity, we have the 5 different levels, starting from the very fundamental or the atomic level, device level, where the use of sensors and actuators is the starting point of achieving very fast level of automation. In the second level, what I was talking about at the very beginning, computer numerical control, coordinate measuring machine, robotic systems, they are all basically standard machines which are fully automated. Then the integration of all these equipment along with the material handling system and overall computerization or the overall control will be taken care of by a central supervisory computer. Then we can have a system level, that is flexible manufacturing cell or flexible manufacturing system. Obviously, FMS is higher, will occupy higher position in the hierarchy of the system over FMC. Finally, plant or factory level, when the entire factory is automated, then we can have plant level or the fourth level of automation. And fifth and the last one, that is the highest level of automation, that is the computer integrated manufacturing, which will be our last topic of this particular course. Now, what is FMS? It is a manufacturing system comprises interconnected CNC machine tools. So that means in a flexible manufacturing system, there will be a number of CNC machines, not a single one. So far, our basic or fundamentals, our discussion were confined to only one CNC machine. But here, it is an aggregation of several CNC machine tools. Predominantly, those are the turning centers or machining centers. Additionally, there will be an integrated automated material handling system, a robust tool management system under the control of supervision of the computer. That means physically we will have a good number of CNC machines, automated material handling system, a robust tool management system. Because cutting tool is also an integral part of the CNC system. We can achieve the very efficient output or efficient performance from the CNC system if we do have a very efficient and well managed cutting tool system. Because apparently it may seem that cutting tool is very trivial as compared to the cost of a CNC machine. But without a very successful, I would say, the appropriate cutting tool, you cannot get the desired result. So the cutting tool selection, corresponding insert selection, identifying what will be the alternative, their transportation, their resharpening if at all required, their procurement, all these activities give rise to the concept of robust tool management system, including automatic toolware monitoring and giving alarm signal towards the replacement. And all these 3 different modules should be that their activity should be appropriately coordinated by a supervisory computer. So that forming an integrated production system which can rapidly respond to changes in production by demonstrating adequate flexibility, agility and adaptiveness. Because this system is utilized to address the mass customization need. That means there will be a changes in the production system. How best or how fast we can respond and how efficiently the system can adapt into the new environment. New environment means in the wake of new demand arises from the customer side. So these are the 3 major attributes: flexibility, agility and adaptiveness. These are adequately demonstrated by the flexible manufacturing systems. Now the most fundamental module is flexible manufacturing module. It consists of the one standalone CNC machine and a material handling device, usually a robot. Why CNC machine is integrated with a robot? If we meticulously analyze what is the total real cutting time or the value addition time and what is the idle time, job loading, job unloading, tool movement, tool changing, these contributes a substantial part or significant part of the total cycle time. Real cutting time may be as high as 50 to 60%, and the rest 40% is loading, unloading of the other idle time. So our objective should be to cut down the idle time as as far as maximum as possible. The robotic system is very efficient in loading unloading the job into the machine tool or particularly CNC machine tool. So if a robot is integrated with a CNC machine tool, then this loading unloading or these sorts of your peripheral activities which are not value additive, those can be successfully and efficiently can be taken care of by the robotic system. So when one machine is looked after by a robot, that means essentially that robot replaces one human labor or operator. So for all sorts of housekeeping tasks. So that is the fundamental of the most your atomic level concept of integration of one machine with a one robot. That gives rise the concept of flexible manufacturing model. Then flexible manufacturing, because one machine and one robot may not be economically viable. When machine is under progress, the robot remains idle. So the cost of investment of the robot is not appropriately justified. To get rid of that and for better utilization, it is imperative that a robot should attain at least look after the 3-4 CNC machines. So that is why FMC consists of more than one CNC machine, usually 3 to 4 machine center, and a robot is used as a material handling devices for loading and unloading of jobs of all the machines. So usually the layout point of view, the robot is considered will occupy a central position, and all the 3 or 4 CNC machines are laid out or scattered almost equidistant from the robot, so that in a standing or one stationary position, the robot can access 3 or 4 machines without moving, but at the same time it will be able to attain means loading and unloading of the 3 or 4 machines nearby without much difficulty. So that will enhance the utilization part on the and also justify the investment for the robot, because industrial robots are extremely costly. So 3-4 CNC machines attended by one single robot, that gives the concept of flexible manufacturing cell. And in the highest level, let us before going to the FMS, this is one scheme of flexible manufacturing cell. Just figure is a little bit hazy. In the left hand side, there is a machine work table, and here we have got a machine tool, and there is a part carousel. So from this robot, this is a robot, a simplified version, which can transport material from the carousel to the one machine. After completion of the job in this particular machine, it can shift or transfer the material from one machine table to the second machine table. So that is how this particular robot can attain one part carousel and 2 CNC machine tool. So that is how it is possible to utilize the robot far better as compared to the flexible manufacturing model. Now this is a flexible manufacturing system. Just you have first identify how many workstations are there and how many robots are deployed. Robot R1, robot R2, robot R3 and robot R4. So these 4 robots are utilized or deployed in a particular FMS. Robot R1 and R2 is supposed to pick up the job from the conveyor C1 and C2 respectively, and robot R3 is utilized to transfer the material from the assembly station to the painting board, and robot R4 is dedicated to carry out painting work. And after completion, the same robot R3 will transfer the job to the output buffer. So how the system works? Additionally, we do have, on the workstations point of view, we have got 2 CNC machines. One is M1, another is M2, and in between there is a assembly station known as AS. So how it will work? So say for instance, there are 2 components. One component will be processed by machine 1 and another will be processed by M2. R1 will pick up the raw part from the conveyor belt C1 and it will transfer it to the machine 1. Similarly, robot R2 will pick up the material from conveyor C2 and transfer it to the M2. So M1 and M2 can work independently. Once their jobs are completed, there is a little possibility that both will be terminated at the same time. So R1 and R2 can work independently. So once the job in the machine 1 is completed, R1 will unload it and transfer to the assembly station. Similarly, after completion of the job by M2, that is the after taking the job from the C2, the robot R2 will transfer the material from the machine 2 and put it to the assembly station. Assuming that the job transferred from the machine M1 and M2 will be assembled in an assembly station. After completion, this robot RC will pick the job from the assembly station and send it or transfer it to the painting station. R4 robot is specialized. It will have a painting gun by which it can paint. After completion, the same robot RC will pick it up and place it to the output buffer. Then it will go outside the system. So this is a complete flexible manufacturing system where material handling systems are there. Tool management system is invisible. You have got two CNC machining center or the turning center, as the case may be, depending on the geometry of the job. Additionally, you have got an assembly station and one painting booth. So, and obviously their coordinated work will be taken care of by the central computer. So that is what exactly is the flexible manufacturing system. So by definition, FMS consists of numerous programmable machine tools connected by automated material handling systems, and their actions are controlled and coordinated by supervisory computer. So let us have a quick look to the number of components. Obviously, machining system, which are comprising either machining centers and the turning center, depending on the part families. Material handling systems, tool management systems, computer control systems. So the system includes CNC machine tools. DMC system is the direct numerical control for the establishing communications. Robotic system for the material transfer. Additionally, there may be shuttle cart AGVs. AGVs is the acronym for Automated Guided Vehicles. I will explain a little bit. ASRS stands for Automatic Storage and Retrieval System, and obviously the Computer and Communication System. AGVs, if we go back to the earlier stage, suppose material ought to be shifted from the conveyor 1 to the say output. So under that circumstance, a long distance to be covered up within the factory itself, and the path is not very smooth. There may be certain bottlenecks of the hindrance. AGVs are also a small cart which can ply to the shop floor. The principle of operation is there is an embedded wire which is laid down beneath the floor, and it has got some light sources, and beneath the car, that is the AGVs, there will be some sensors which can pick up the signal, and according to the emitted signal and the signal received by the two sensors installed on the onboard AGVs, it can track the path where from it will have to pick up the job and where it has to be disposed. So that may be one principle of operation. Another may be the floor can have a painting of the fluorescent paint, which can guide or control the particular AGV to maneuver or to move from the one location to other location by avoiding any collision and or navigating to the different bottleneck paths. So ASR and so that is what about the automated guided vehicles. And ASRS is basically a station for palletizing the raw material and depalletizing. That means when material is procured from the market and it reaches the factory shop floor, it has to be stacked at a particular location, and that is also usually taken care of by the robotic system. So that is what exactly is called automatic storage, and during processing it has to be shifted from the location to the different machine station. So we ought to retrieve those items from the stock, that is called retrieval system. So automatic storage, that is called palletizing, and retrieval, that requires or that is used for the your depalletizing. Both are also taken care of at a different location, of course, on the unmanned system and predominantly by robot. And additionally, some shuttle cart also may be deployed. So machining systems, DMC system, robots, your transport system, and computer communication systems are the essence of, or they are the four modules that comprises flexible manufacturing system. So based on the program, based on your planning, the system can be utilized to convert the raw material to the finished component, of course, offering a lot of adaptability, flexibility, and the agility. There are different viewpoints of the term flexibility. One is product flexibility, the ability of accommodating product design changes. That is why the flexible system is required to, or is utilized to address the challenges of mass customization or the mass personalization. And at that time, when it was proliferated or introduced in the 1980s, at that time batch manufacturing was predominant. Objective is the flexibility. For flexibility, different products can be manufactured by the same facilities only by altering the software of the programs. Production flexibility, the range of parts, types, or features that can be produced in the system. Today, a particular component may have 4 or 5 different features. Tomorrow, we have to deal with another job where some 5 or 6 features, 2 or 3 additional features are there. So, if the system without much difficulties, simply by altering the program, can accommodate or can deal successfully with the present job or with this existing system, then we can have that the system manifest adequate flexibility, basic flexibility. Operation flexibility. Alternative operation sequence can be used for a processing part type. Depending on the situation, the sequence of operation may require to be changed. If it is possible, then we can say there is adequate operation flexibility. Routine flexibility, the alternative path that a part can effectively follow through a system for a given process step. Material needs to be shifted from one location to other location following a definite route. But if there is any bottleneck, if there is any failure in the existing system, if there is a new development, there is certain bottlenecks which are not planned earlier. But if there is adequate flexibility, then the system will find out the alternative path so as to avoid any collision, and it can carry out its or keep on continuing its operation without much wastage of time or delay. Volume flexibility, measure of system's capability to be operated at a different volumes of existing part type. Definitely, in this particular paradigm, we talk about the term business term, that is product volume mix. So that means volume also may change depending on the different product categories or the product variants. Say model A may require 20 numbers, model B may require 25 numbers, model C may require 37 numbers. So different categories of model A, B, C, and their quantity also keeps on changing. That is what exactly is called product volume mix. So the system must be capable of taking care of ups and downs of the volume changes very efficiently without any confronting any difficulties. And expansion flexibility, ability to build a system and expand. There must be ample provision that in future there is some additional alteration of the equipment of the system component. Mostly your conveyor system, maybe your material handling other systems. Instead of having 2 AGVs which is running currently, there will be additionally 1 AGV is added, or 1 or 2 additional machining centers are installed. So there must be possibility of the scope or provision for expansion. So flexibility is a very generic term, and it has got a different dimensions, and these are some of the very prominent dimensions by which we can define or view the flexibility. So that is, I believe, all about. Finally, the last slide will be the what are the potential advantages we can achieve to reduce setup and queue times. That means waiting time must be much less. Improved efficiency, because through this system the time taken by the systems is very less, and due to improvement in the consistency, quality, reduction in scrap, we can have a very higher output. Reduce time for product completion. That means entire cycle time will come to a very small one. That means substantial time can be reduced. That is the main motto. Utilize human workers better. Since day-to-day machine activities or your housekeeping activities are not need to be taken care of by the human operator. So that is why the human can be deployed for better work or activities which require some sorts of more intelligent decision making or critical thinking. Produce a variety of items under one roof. This is what exactly is the main objective from the business perspective. Different variants can be manufactured under one roof without any addition or alteration of the physical systems of the machines. Improve product quality, it is same as the before. Serve a variety of vendors simultaneously. If more such 2 or 3 customer orders are taken care of or manufactured or under development simultaneously, that can also be taken care of very successfully. And the majority of the bottlenecks can also be mitigated through the intelligent decision making, fault finding, that is the inbuilt diagnostic features. Produce more product more quickly. That means it can cut down the lead time drastically. So these are some of the major advantages that we can achieve to the flexible manufacturing system. One thing I would like to highlight, in the current days, year 26, 25, 25, 26, we are talking about the smart manufacturing. Earlier, in the context of the flexible manufacturing system, we used to talk computerization in manufacturing, but in the current days, we talk about the digitalization in manufacturing. So, computerization and digitalization has got a difference. Digitalization is much more advanced and it is driven by or motivated by data-centric decision making, where we do have cyber physical system, digital twin, smart manufacturing. So under these circumstances, whenever we talk about the smart manufacturing, in 2020 or 25, we have got very sophisticated networking and wireless communication. But this FMS, since it is within one factory, within a limited distance to be covered up, so the connections and the communication was more or less or more about wired network. That means through RS232C or say LAN connection or some Ethernet connection. But don't confuse that the state of the art communication system which we can enjoy in the 21st century, those level of sophisticated communication system was not prevalent when FMS was become popular. But FMS serves as a potential background based on which considering this as a foundation, then the current days cutting edge technology intensive smart manufacturing are in force. So that is all about the flexible manufacturing system. I believe that it will be a valuable input to your study. And finally, the last discussion will be on the computer integrated manufacturing to offer the entire security. So that's all. Thank you very much.